Good afternoon, class. We are looking at trigonometric functions, section 3, properties of trigonometric functions. So we covered 5.1 and 2, angles and their measures, trigonometric functions, unit circle approach, and properties of trigonometric functions. The objectives are find the domain range and
Which one is
trigonometric functions. Determine the signs of the trigonometric functions in a quadrant. Find the values of the trigonometric functions using fundamental identities. Find the exact values of the trigonometric functions for an angle given one of the functions and the quadrant of the angle. Use even odd properties to find the exact values of the trigonometric functions. So reminding you of what we have seen, definition of a vertex, line versus ray, initial side, terminal side, counterclockwise, positive angle. Clockwise rotation is negative angle. Standard position, the initial side is along the x-axis, and that in this case, counterclockwise is positive. This one is negative. Quadrantal angle, the initial side, as always, is along the positive side of the x-axis. The terminal side is along one of the axis, the positive or negative side of x, the positive or negative side of y. 1/4 of a revolution, or 90 degrees, or right angle. Half of revolution, or 180 degrees, or pi radians. A complete revolution is 360 degrees, or 2 pi. And the relationship between the two is d over 180 is r over pi. A complete counterclockwise revolution gives us 360 degrees, as it was mentioned. 1 degree is 60 minutes, 1 minute is 60 seconds. Arc length, S, is r theta. Area of the sector, half of r squared theta. Angular speed, omega, is theta over t. 2 pi times RPM, linear speed, is S over t over r omega, just to remind you of that. As far as the unit circle is concerned, remember, circle has the equation x squared plus y squared equals r squared, centered at 0, 0. If the radius is 1, becomes a unit circle, x squared plus y squared equals 1. And with that, a point on the curve with coordinates x comma y. X is represented by cosine, y is represented by sine. And as long as we know these two, we can figure out the rest, because tan is y over x or sine over cosine. Cotangent, cosecant, and secant are the reciprocal of those. If we go with a circle such that it's not a unit circle, the radius is any r, x squared plus y squared equals r squared, and the point has coordinates a comma b on the circle, so sine instead of y becomes y over r. Cosine instead of x becomes x over r, and tangent, of course, sine over cosine, which is y over x, and the rest of them are the reciprocals, as always. All right, I want to remind you of what we have seen before. These are the exact values of the trigonometric functions of some common arcs, such as pi over 6 or 30 degrees, pi over 4 or 45 degrees, pi over 3 or 60 degrees. We should be familiar with those. And hopefully we have already memorized them. Those are very easy to remember. We've seen it, we should have seen it before. And of course, sine t equals y or sine theta equals y, depending whether you approach it as an arc or angle. properties of trigonometric functions, domain and range of trigonometric functions are given here. And I'm going to summarize it here. Sine, the domain is all real numbers. Cosine, the domain is all real numbers. And in both cases, the range is from -1 to 1. Tangent theta, all real numbers, except 2n plus 1 times pi over 2 means odd multiples of pi over 2. The range is -infinity to +infinity. Cotangent theta has the same range, r minus n pi. That means integer multiples of pi must be excluded. Secant theta is following the tan theta, and the range, everything except anywhere between -1 and 1, we say -infinity to -1, union 1 to infinity. Cosecant theta follows cotangent, in essence, r minus n pi. That would be the domain. The range is the same as the range of secant theta. Anything between -1 and 1 would be excluded. This is the summary. So sine is always between -1 and 1, and cosine is also between -1 and 1. Cosecant is less than or equal to -1 or larger than or equal to 1. We are, in essence, looking at the range, which works the same way for secant. Tan and cotangent, they can be any number from negative to positive infinity, the y value, if you will. All right, let's look at this page and the summary of that. Determine the period of the trigonometric function. So first and foremost, a function f is called periodic if there is a positive number p such that whenever theta is in the domain of f, so is theta plus p, and f of theta plus p equals f of theta. If there is a smallest such number p, the smallest value is called the fundamental period of f. Take a look at the concept. Sine of theta plus 2 pi k equals sine theta. Cosine of theta plus 2 pi k is cosine theta. K is any integer. Sometimes we use k, sometimes we use n. The idea is that, as you recall, 2 pi is a complete revolution, puts us back in the same spot. So if we add 2 pi or multiples of that, we still end up with the same location. That's why sine and cosine are the same. So the period for all trigonometric functions would be 2 pi. In the case of tangent and cotangent, would be pi. So if this angle or arc is a pi over 3 and you go a complete revolution, 2 pi plus that, you end up at the same spot, and that's why we have the same values as far as the sine and cosine, and therefore secant and cosecant are concerned. So if this is theta plus pi. And what happens is, when you go with pi radians, both values here are positive in the first coordinate, meaning x and y, meaning sine and cosine. Of course, x and y, maybe you should say cosine and sine, because x represents the cosine. When we add pi, we end up in the third quadrant, in which case both of them are negative. So because tan theta, by definition, is sine over cosine, in this case, positive over positive, in this case, negative over negative, they end up giving you the same answer. Therefore, the period for tangent and cotangent is pi. So for example, tan of pi over 4 is 1. Tan of 5 pi over 4, which is pi plus pi over 4, is the same thing. So we want to pay attention to the period. So the period is 2 pi for every trigonometric functions except tangent and cotangent is pi. But by the way, if pi is a period, so is the 2 pi. Okay. but remember the fundamental period, the smallest value. All right, so I want to find the exact values using the properties we just discussed. So what you do, whatever this value is, you add or subtract multiples of 2 pi, so you bring it into the first revolution, okay? Somewhere between 0 to 360 or 0 to 2 pi. You should recognize 16 pi over 4 is 4 pi. 16 pi over 4. So this number or 16 pi over 4. And 4 pi is 2 times 2 pi. Any multiples of 2 pi will do it. Therefore, this is equal to sine of pi over 4. Therefore, is equal to square root of 2 over 2. All right, when we look at the next one, 5 pi, everybody. What do we notice about 5 pi is larger than 2 pi. So you have to subtract multiples of 2 pi because it's cosine. So you can subtract 4 pi again. And therefore it's the same as cosine of pi. And we know cosine of pi is negative 1. So very straightforward, everybody. What about tangent? We said the period is pi. This number is larger than pi, subtract pi. So 5 pi over 4, subtract pi, in essence, the same as pi over 4. And tan of pi over 4, we know it to be 1. Determine the signs of a trigonometric functions in a quadrant. Bear in mind, x comma y, the first quadrant, x is positive, y is negative. The first quadrant, y is positive. So in the first quadrant, everything is positive. X represents cosine, y represents sine. But for example, if we go to the second quadrant, x becomes negative. That means cosine is negative. If we go to the third quadrant, both x and y are negative. That means x representing cosine and y representing sine. Sine and cosine are both negative. Whereas here in the fourth quadrant, x is positive. That means cosine is positive. Y is negative. That means sine is negative. And the same thing follows as far as the rest of them are concerned. Tangent, by the way, secant and cosecant. Secant follows cosine and cosecant follows secant. Tangent and cotangent, both of them are positive here and here, negative in these two. So x squared plus y squared equals 1. P has coordinates x and y. Sine is represented by y. Cosine is represented by x. Just as an example, in the fourth quadrant. So in the fourth quadrant, cosine is positive, sine is negative. We can figure this out. Now, tan is y over x. We're discussing this one. And because they have different signs, therefore this becomes negative. cosecant, the same as sine becomes negative. Secant, the same as cosine becomes positive, and cotangent and tangent have the same sign. Now, here's the general idea. All positive. By all, we are referring to the first quadrant, and this is cosine and sine. Then it becomes negative, positive, negative, negative, positive, negative, and so forth. And then we go to sine, cosecant, cosine, secant, tangent. As long as you know x and y, and as long as you know that x represents cosine, y represents sine, you can figure out the rest of it. Okay, again, secant, the same as cosine, because secant is 1 over cosine, whatever the same sign. Okay, cosecant has the same sign as sine because it's 1 over sine. Cotangent has the same sign as tangent because it's 1 over tangent. And tangent is y over x. So if one of them is negative, by that I mean either sine or cosine, this becomes negative. So do I have to memorize that? If you want to memorize it, it becomes very difficult. All you have to remember is a point as coordinates x and y, and x is cosine, y is sine. As long as you remember that, you don't have to memorize anything because you know everything there is to know about quadrants and what's going on with x and y. Okay. Finding the quadrant in which an angle lies. If sine is positive and cosine is negative, name the quadrant in which the angle theta lies. So we start with the first one. We say sine is positive. That means y is positive. So it's either in quadrant 1 or 2. What about cosine? Cosine is negative. Cosine is represented by what? X. So in fact, if it helps, just you can even say, okay, this is represented by y, this is represented by x, and x is negative in the second and third quadrant. What's in common here? These two. So has to be in quadrant 2. Has to be in quadrant 2. Very straightforward, everybody. I hope everybody's okay with this. Okay. Fundamental identities. Here's the synopsis of that. First, we start with, and we're going to explain them in a moment. X squared plus y squared equals 1. And a point has coordinates x comma y or cosine theta comma sine theta. If x squared plus y squared is 1, then cosine squared plus sine squared or sine squared plus cosine squared must be 1. So this is one of Pythagorean identities. Now to get to the next ones, you divide both sides in one case by cosine squared, in the second case by sine squared. If you divide by cosine squared, this becomes 1. This becomes sine over cosine, tangent squared. This becomes secant squared. So we prove tan squared plus 1 is secant squared. So this one, the proof comes from the unit circle. This one divide by cosine squared. To prove this one, we're going to divide both sides, this time by sine squared. So this becomes 1. This becomes cotangent squared. This becomes cosecant squared, which is the last one. So what you're looking at as fundamental identities, we have the quotient identities such as tan theta is sine theta over cosine theta, cotangent is cosine theta over sine theta. We have reciprocal identities, cosecant is 1 over sine. By the way, if cosecant is 1 over sine, sine is 1 over cosecant. Secant is 1 over cosine, cotangent is 1 over tangent, and here's the Pythagorean identities. There are a lot of identities here. I hope you remember most of them from high school. Find the values of a trigonometric functions using fundamental identities. For example, we want to find the exact value of all trig functions. If sine is square root of 10 over 10, cosine is 3 square root of 10 over 10. And we are going to use the identities. So for example, if we start with the quotient identities, we know tangent is sine over cosine. So sine over cosine will result in tangent. The common denominator is 10, you can drop it. Square root of 10 is common, you can drop it. The answer is 1/3. And the rest of it are the reciprocals, everybody. So practically you're done. You have the sine, that means you have the cosecant theta. So here's the reciprocals. Cosecant is 1 over sine. So this becomes 10 over square root of 10, and that is square root of 10. If you have doubts, basically you multiply by square root of 10 over square root of 10, and you see you get 10 square root of 10 over 10, which gives you this answer. Anyways, so that's rationalization. Now cosine theta is this number, 3 square root of 10 over 10. Secant theta is the reciprocal of this. Which means 10 over this. And I hope again you can see that you can multiply by square root of 10 over square root of 10, and it becomes that. I'm hoping we have no problem with rationalization. Again, if I wanted to show that this is what we get, you multiply this one by square root of 10 over square root of 10. The top becomes 10 square root of 10. And the bottom becomes, let's say not 30, let's say 3 times 10. So they can cancel each other. Square root of 10/3. These are precise answers. You have to answer in precise. So tan theta is given as 1/3. Cotangent is the reciprocal of that. Makes it 3. Very simple, everybody. All right. So a quick recap. Sine was given. Cosine was given. Tangent is sine over cosine. After you find that, the rest of them, you use the reciprocals. Okay. Finding the exact values using items. Find the exact value of each expression. Do not use a calculator. 1 over cosecant squared 35 degrees plus cosine squared 35 degrees. Okay. I hope you recognize 1 over cosecant is sine. Okay. Cosecant is 1 over sine. So 1 over cosecant is sine. So this is sine squared. 35 degrees. This is cosine squared 35 degrees. And the very first Pythagorean identity says it's 1. Cosine of power 3 over sine power 3. This minus cotangent power 3. I hope you recognize this one, cosine over sine, as cotangent. Therefore, they cancel each other. We get 0. I'm putting the identities here. You really have to get very comfortable with them. Tan Tony minus sine over cosine Tony. I hope you recognize this is tan, and so is this one, because by definition of a tangent, which is sine over cosine, this becomes tan Tony, and the answer is 0 because they cancel each other. Okay, that's the quotient identity, if you will. Sine squared power 12 plus 1 over secant squared power 12. So I want you to concentrate on this one. 1 over secant is cosine. See, secant is 1 over cosine. So this is 1 over secant is cosine. So this is cosine squared. And again, going back to the very first Pythagorean identity, sine squared plus cosine squared. Both of them have the same argument, power 12. The answer is 1. Find the exact values of the trigonometric functions of an angle given one of the functions and the quadrant of the angle. There are different methods. One of them is using circles. So how do we do that? Draw a circle. Circle of radius r, center that's 0, 0, x squared plus y squared equals r squared, a point with coordinates x comma y, r equals square root of x squared plus y squared, or x squared plus y squared equals r squared. Assign a value to 2 of the 3 variables based on the value of a trigonometric function that is given. Calculate the missing variable. Use the formulas to find the rest. Pay attention to the quadrant and the sign. So these are the formulas, right? The second method is to use identities, which means you have to remember all the identities that we discussed: Pythagorean identities, quotient identities, reciprocal identities. And one may be easier than the other. It's your choice. Ultimately, you should know both methods. All right, for example, we want to find the exact value of all trigonometric functions, okay, where sine is 2 over 5 or 2/5 and cosine is negative. And we are going to do it 2 ways. First, we're going to deal with the circles. Now, understand sine is positive. That means the first or the second quadrant. Cosine is negative, and that gives you quadrant 2. Please understand. And by the way, those are the formulas we know. So we are in quadrant 2 again because sine is positive. Sine, it's positive. It's in the first. This would give you either quadrant 1 or quadrant 2. This is negative. That gives you quadrant 2 or quadrant 3. So 2 is in common. We are in the second quadrant. In the second quadrant, okay, x is negative, by the way. So we need x, y, r. Sine is y over r, which is 2 over 5. So if you choose y is positive, because we're in the second quadrant, y is positive. R is always positive, class, okay? It's x and y that one of them may be, or even both of them may be negative. So Y is 2, R is 5. Use x squared plus y squared to find the missing x. So we have coordinates x comma 2, R is 5. When we plug in a 2, in this case, 2 squared becomes 4, y squared becomes 25 minus 4, 21. My apologies, x squared. Okay. Because this was 4. Y squared is 4. X squared is 21. So x is plus minus square root of 21. Now, we pay attention to this and we choose the proper signage. Is this negative or positive? Second quadrant, x is negative. So you can't choose both of them. Which one do we choose? According to the second quadrant, x is negative square root of 21. And now just plug in. So sine is y over r. Cosine is x over r. So this one over 5. Tangent is y over x. So 2 over square root of negative 21. Oh, I said x over r, didn't give you the answer. Square root of negative 21 over 5. And that's an exact answer. Tangent is y over x. Y is 2. X is negative square root of 21. And you rationalize it. I'm going to leave it for you to rationalize. Again, all you have to do multiply by square root of 21 over square root of 21. You know how to rationalize. Let me just show you. So you multiply the top and the bottom by square root of 21. And this is what you get. Cosecant theta is r, which is 5, over y, which is 2. Okay. Secant theta is r, which is 5, over x, which is minus square root of 21. And again, rationalization. Cotangent theta is x over y. So this number over this number. So this would be using circles. It's pretty straightforward. Let's look at the same question using identities. Let's look at the same question, everybody. Now we want to use identities, so we remind everybody of the identities, and because sine is given, it's very simple. Go to the very first one and say sine squared plus cosine squared is 1. And by the way, we discussed the quadrant already, so I'm not going to go over that again. It's obviously the same quadrant. So sine squared plus cosine squared is 1. Replace the sine with 2 over 5, which is 4 over 25. And subtract it from 1. You get 21 over 25. And cosine is plus minus the square root of 21 over 25, which comes out as 5. Now again, is it positive or negative? You have to choose it accordingly. We proved that it's in the second quadrant. In the second quadrant, cosine is negative. In fact, it mentions it here. So you have to choose the negative one. So it's just mentioned here. Since you have sine and cosine, practically we're done because tangent is sine over cosine. This number over this number. And again, I'm assuming we can go from here to here. First, you can drop the common denominator of 5. So 2 over negative square root of 21 We multiply by square root of 21 over square root of 21, and we get this. Now that we have those, just the reciprocals, the easiest one. So, for example, the reciprocal of sine gives us cosecant. The reciprocal of cosine gives us secant. Since we are here for tangent, so the reciprocal of this, look at this one. The reciprocal, this is easy. You don't have to rationalize it then. The reciprocal of this is cotangent. So cotangent is minus square root of 21 halves. Okay. Sine 2 over 5, cosecant 5 over 2. Cosecant 1 over sine theta, 1 over 250 is 5 halves. Cosine minus square root of 21 over 5. Secant is the reciprocal of this. Again, this is the answer, and this is rationalization. So it's rationalized in this case. Again, just multiply by square root of 21 over square root of 21, and it gives you that, okay? Let's look at another example. We want to find the exact values of all trigonometric functions where cotangent theta is 1/3, sine theta is negative. So the very first thing is to figure out the quadrant. Cotangent and tangent are positive in the first and third quadrant. So this gives us, because it's positive, quadrant 1 or 3. Sine is negative in the third quadrant and the fourth quadrant. So this will give us quadrant 3 and quadrant 4. As you can see, number 3 is in common. So theta belongs to the third quadrant. So going with x and y, cotangent is x over y. Why are we choosing both negative? Because we said it's the quadrant 3. You can choose both positive if it's in the first quadrant. In the third quadrant, both are negative, and therefore 1 squared plus 3 squared, or negative 1. The class, we are really adding this 2, if you will. The reason I didn't put negative, it makes no difference when you square it. But it's really, you just put it as negative 1 to be on the safe side, okay? Yeah, that's better to do it that way, okay? Just put a negative sign so you recognize that you're dealing with negative 1 quantity squared, which becomes the same thing, by the way. Okay. In any event, the purpose of this is to find the R, and this is 1 and 9, 10. R squared is 10, and R is square root of 10. R is always positive. All right, we are good to go. Cotangent theta is x over y, so tan theta is y over x. Y over x, which becomes positive 3. Ultimately, you can mix and match this method with the identities, but if they ask you a specific method, you should be able to handle it. Sine is y over r. So negative 3 over square root of 10. And again, rationalization, multiply. The top by square root of 10 and the bottom by square root of 10. I'm hoping nobody has any problem with rationalization. Cosine is x over r, so minus 1 over this number. However, the faster way maybe we go with the cosecant, which is r over y. So you can have the reciprocal of that, and you don't need to rationalize. Cosine is x over r, negative 1 over square root of 10 must be rationalized. So multiply by square root of 10 over square root of 10. And the secant is the reciprocal of this, r over x. And by the way, don't ever write a fraction with the denominator being negative 1. Make sure you get rid of that, minus square root of 10. So this was the method of circles and using the fact that x squared plus y squared equals r squared. We want to look at the same question using identities. So it's the same question and it's the same quadrant that we discussed in the previous page. Cotangent is positive in the first and third quadrant. Sine is negative in the third and fourth quadrant. Quadrant 3 is in common. So we use one of these identities. In this case, because this is cotangent class, we're going to use the third one, 1 plus cotangent squared, or cotangent squared plus 1 is cosecant squared. You replace this with 1/3, and we recognize this is 1 over 9, with 1 becomes 10 over 9. Cosecant is plus minus the square root of this number, which becomes plus minus the square root of 10 over 9. The 9 comes out as 3. Now, there are two answers. We have to choose the proper answer. Remember, we are in the third quadrant. In the third quadrant, everything is negative except tangent and cotangent. Therefore, you have to choose the negative sign. Since sine theta is less than 0, cosecant theta is negative. That's another way of looking at it. But again, third quadrant, everything is negative except tangent and cotangent. Those are the two that are positive. Now, cosecant and sine, they have a relationship. And that is cosecant is 1 over sine, or sine is 1 over cosecant. Makes no difference. And so with that being the case, the reciprocal of this is the answer for sine, which becomes negative 3 over square root of 10. And again, you can rationalize. By now, you should have no problem with rationalization. You've seen it many times before. Okay, so we have cotangent theta as 1/3, which means tangent must be 3 over 1, or simply 3. Now, the last thing is cosine theta. Now, there are different ways of approaching it. One is, we know that tan theta is sine over cosine. And remember, we have the tangent, we have the sine. We can plug in and we find cosine. I hope you recognize algebraically you can interchange these two because we can do the cross product. Which means cosine theta is sine theta over tangent theta. This is very important to know. This has got to do with understanding cross product. So sine theta is this one, including the negative sign, and tan theta is simply 3. And so what happens is that 3 cancels out the 3, and the remaining is minus square root of 10 over 10. Finally, secant theta is the reciprocal of cosine. And the reciprocal of this, everybody, is minus 10 over square root of 10. And I hope you understand that. Since square root of 10 times square root of 10 is 10, this becomes minus square root of 10. Or rationalize. Either way is fine. So we looked at a couple of examples, two different ways using circles, using identities. You ultimately have to be comfortable with both because sometimes one is easier than the other. All right. Use even and odd properties to find the exact values of the trigonometric functions. Every trigonometric functions is an odd function, meaning, for example, okay, let me just remind you the meaning of odd. Odd function was f of minus x is minus f of x. This was odd. Even f of minus x equals f of x. All of them are odd except cosine. And with cosine goes secant. Remember, cosine and secant are reciprocals. Okay, so every trigonometric function is odd. So sine of minus theta is minus sine theta. Therefore, cosecant minus theta is minus cosecant theta. Tan of minus theta is minus tan theta. Cotangent minus theta is minus cotangent theta. You take the negative outside the argument. But for cosine, cosine of negative and positive is the same, so is the secant. And here's the reason. Because the first and the fourth quadrant, the x is positive, which is the cosine. So whether we go with theta or negative theta, we have the same x. Okay, so that makes it an even function. So cosine of minus 60 is the same as cosine of 60, making it 1/2. We should know it's 1/2, by the way. Sine of negative 390, we take the negative out because it's an odd function. We also recognize 390 is larger than 360. By the way, when 2 pi is a period, so is 360 degrees, okay? So for sine and cosine, for example, so if the period is 2 pi, it's equal to 360 degrees. Sometimes we say 2n pi, 2k pi, or 360 times n or k. And for tangent and cotangent, pi or n pi. So 390 is the sum of two numbers. One of them is 360. So 360 plus what number? 30 degrees. And so the answer is sine of 30. Keep the negative. Minus sine 30, you should know sine 30 is 1/2, so negative makes it negative 1/2. Tangent is an odd function. Take the negative sign out. 37 pi over 4 is larger than pi. So take out multiples of pi. Notice 36 pi over 4 is divisible by 4. And this is 9 pi. Multiples of pi are a period. The pi is the fundamental one. And so this is the same as tan of pi over 4. Keep the negative sign. And therefore, tan of pi over 4 is positive 1. The negative sign makes it negative. The answer is minus 1. So knowing when we use even and odd properties, knowing the even and odd will help us evaluate these trigonometric functions. Pretty straightforward class. If cotangent theta is negative 2, we want to evaluate the expression cotangent theta minus pi, cotangent theta minus 2 pi. Remember, the period for cotangent and tangent is pi. When we say pi, any multiples of pi, positive or negative makes no difference. So this is cotangent. This is minus pi. This is also cotangent theta. And this is minus 2 pi, also cotangent theta. So we have three of those. And so 3 times negative 2 is negative 6. Please understand the period for tangent and cotangent is pi. So any multiples of that will result in the same function. We want to find the exact value. Sine of 1 degree, sine of 2 degrees, all the way to sine of 359 degrees. We want to make sure we understand this concept and how easily we can come up with the answer. So we keep those 357 degrees. I want you to see that if I go 357 degrees, I have 3 degrees left to get to 360 degrees. Again, for sine, remember for sine, the period is 2 pi or 360 degrees. So if we go, just for the sake of argument, here, this is not to scale, and we stop at 357 degrees positive, this would be minus 3 degrees. And that means the sine of 350, the sine of 357 degrees and the sine of minus 3 degrees end up at the same point. They must have the same value. So I can replace this with sine of negative 3 degrees. I can replace this with sine of negative 2 degrees. I can replace this with sine of negative 1 degrees. And because they are odd, I can take the negative out. So minus sine 3, minus sine 2, minus sine 1 degrees. So this thing continues, and what do we find? So first of all, this part, I want to make sure we understand that this part is here, and this part is also here, and they cancel each other. So everything cancels out. This goes all the way to plus 179, and this goes to this is 181 degrees, everybody. This is plus sine 181 degrees or minus sine 179 degrees. That's why they cancel each other. So everything cancel out. What remains is sine of 180. And sine of 180 or pi, we should know it's 0. So pay attention to what I explained here. We are going to look at the same thing, but this time for cosine. Cosine of 1 plus cosine of 2 all the way to cosine of 359 degrees. And so, again, I want you to understand the concept here. So we're going to keep the first 3 and the last 3. 359 means what? The same as negative 1, right? 358, negative 2, 357, negative 3 degrees. Just as we did, this is identical to the previous page, everybody, but sine has been replaced by cosine. However, cosine is an even function. So we have to change this to cosine of positive 3, cosine of positive 2, and cosine of positive 1 because it's an even function. So we have 2 of this, we have 2 of this, we have 2 of this, and we go all the way to 179 degrees, 2 of that. Cosine of 180 is the only one which is 1. So please understand, cosine of 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, all the way to 179, we have 2 of those. The one right smack in between 180 is just 1. Okay. Now, what is interesting to know that in essence, these two cancel each other. The reason they do, because this is 180 minus 1. This is 180 minus 2. So let me write that. Now, cosine of 1 degrees and cosine of 179 degrees. They are identical, but they are opposite as far as the sign is concerned. Because I want to make sure we understand what's happening. If this is 1 degree, let's make something that, just, let's say this is 20 degrees. And this is 160 degrees, where the two numbers, they add up to 180. Remember, this is the reference arc, everybody. This is the reference arc. And they have the same value, except in the first quadrant, cosine is positive, in the second one is negative. So they undo each other, all of them. This one undoes this one. Okay, 1 degree, 180 minus 1. 2 degrees, 180 minus 2. 3 degrees, 180 minus 3, and so forth. All of them cancel each other. So, again, I want to make sure we understand. This one cancels out this one. This one cancels out this one, and so forth. So you're left with cosine of 180, and cosine of 180 is negative 1. Last example, example 10. From parking lot, you want to walk to a house on the ocean. So here's the parking, and you want to go to this house, which is 500, the house is located 1,500 feet down a paved path. This is 1,500 feet. That parallels the ocean, which is 500 feet wide away. So this distance is 500. This distance is 1,500 feet. Along the path, you can walk 300 feet per minute. Over here, 300 feet per minute. But in the sand on the beach, you can walk only 100 feet per minute, so slower. See the illustration. So we want to go from the parking to the house. Some of it we use the paved path, some of it in the sand. We have many choices. We can go straight to here and then here, or at some point we make the turn, or go only directly from the sand. So there are many different ways. The time t to get from the parking lot to the beach house can be expressed as a function of the angle theta. This is the angle that you choose to make. At some point, you turn towards the house, walking on the beach. It may be 90 degrees, or maybe some other angle, or just right from here. So it depends on theta. So the time t to get from the parking to the beach house can be expressed as a function of the angle theta, shown in the illustration, and is as follows. T of theta is 5 minus 5 over 3 tan theta plus 5 over sine theta, where tangent is somewhere between, theta is between 0 and pi over 2. All right. Calculate the time t if you walk directly from the parking lot to the house. So if we go directly, it looks like this. This distance doesn't change, it's 500 feet. This distance doesn't change, it's still 1,500 feet. but we are going directly making this type of angle, theta. And so we can figure out everything else. So we're going to call this R, and tan theta is the opposite, 500 feet over the adjacent 1500 feet. So this one is y over x in essence. So this is y, this is x, where r squared is x squared plus y squared. So we add them up. You can add them up using 500 and 1500, or you can add them up using 1 and 3. The ratio is 1/3, makes no difference. So you can use 1 and 3, and you get 10 because we are interested in the ratio. Let me actually erase my box so you can see. So you can use 1 instead of 500, 3 instead of 1500, or become square root of 10. This is for the sake of calculation. If you use 500 and 1500 works perfect. You can calculate the radius using Pythagorean theorem, just like that. Again, x squared, that means 1500 squared, plus y squared, that means 500 squared, and you find out it becomes huge. So this one, we can do it even in our head. We don't need a calculator. And so what is the next step? Sine theta is the opposite, okay, over the hypotenuse. So 500 over that large number, or easy 1 over square root of 10. It's easier to, it's the same ratio. Why are we calculating that? Because when we look at this formula, we need to know the tangent, which we found it to be 1/3. And we need sine, that we have it as 1 over square root of 10. So this is the answer, and we're going to simplify it. But you want to keep the exact answers until there is time to simplify. So please understand these two cancel each other, become 1. So 5 minus 5, and this one that comes up becomes 5 square root of 10 precisely. Okay, 5 square root of 10 precisely. And roughly 15.8 minutes. So if we go straight from here, it takes us 15.8 minutes to get there.